So whatever you get x alone in the middle, you do to all three sides. So I have an open circle at 2/5, open circle at 2, and then when it's sandwiched in the middle here, you always shade in the middle. So x is less than 2 and x is greater than 2/5. It's kind of like if x is sandwiched, it's in the middle. So it's less than this and greater than that. So for example 6, same thing. Whatever you do to get rid of x in the middle, you have to do to both sides. So first thing I would do is multiply by 3 to get rid of the denominator. So then that means I have to multiply the right by 3 and multiply the left by 3. So 3 times 0 is 0. 5 times 3 is 15. Then I would subtract 5. So then that means I have to subtract 5 to the right and 5 to the left. And then lastly, I would divide by -2. So then that means I have to divide all the sides by -2. So then -5/2 is the same thing as +5/2 because negative over negative is a positive. And then since I divided by a negative, I have to flip all my signs. So I have to flip this sign over, and I have to flip the other sign over. 10 divided by -2 is -5. Just draw your number line since it didn't print. So open circle at -5, open circle at +5/2. X is greater than -5 and x is less than 5/2. So you're still sandwiched in between. It's just flipped on you. So we went through a lot today. We're going to practice tomorrow. But if they're and statements, these are the special cases. You're looking for where they overlap. And if they don't overlap at all, you don't have a solution. So this one overlapped to the left. This one didn't overlap at all. For or statements, you just shade whatever they tell you, this or that. You could have any answer. They don't have to overlap. And then down here, when it's sandwiched in the middle, you have to solve for it in the middle, and then your shading goes in between because there are X's sandwiched there.